Alright guys, let's take a look at a couple of problems here. Right now I'm looking at a triangular prism. So in fact the first thing I'm going to ask myself is how many triangles do I see in this triangular prism? Well, I can see one along the front side here, and if I look to the opposite side there's one running parallel to it along the back side of this prism. Cool. So I'm just going to highlight those so they stand out a little bit more, and I'm going to make a note that I see two triangles here. So there are two triangles. And the next thing I'm going to do after that is just make a little line underneath and then go ahead and draw one triangle. And I'm going to mark dimensions of both triangles for my shape that I just drew. So let's go ahead and choose a new color. Well, I know that the height here is 3 feet, or not 3 feet, 3 centimeters. The base of this triangle is 4 centimeters. And the hypotenuse, or the longest side of the triangle, well, it's along the back side here. We see it's 5 centimeters. So I'm going to make a note that this is 5 centimeters as well. So the next thing I want to do after that is just write the area formula for a triangle. What is the area of a triangle? Well, the area is equivalent to A is equal to half times the base times the height, or base times height divided by 2. Either one would work. I'm going to use this formula today. The next thing I want to do is just make a little bit of a divider and ask myself, how many rectangles do I see? Well, I see 3 rectangles, but I don't know that they're all the same size. So I'm just going to draw 3 individual rectangles below. So here's one rectangle, a second rectangle, and a third rectangle. Great. And I'm going to erase the highlighted information for our triangles. And okay, so we have a highlighter here, and the first one I want to look at, the first rectangle, is along the back side of this triangular prism. So if we just highlight along that dotted line and then highlight upward from here and then come on back, travel back. Well, what would be the dimensions of this rectangle along the back side? Well, I can see it has a height of 3 centimeters. Therefore, I could call it the height or the width. I'm just going to label this side right here with the 3 for 3 centimeters. And the next thing I'm going to do is ask myself, what is the length of this rectangle? Well, the length, I can't see it here, it's not written down, but I can see that the length of this next rectangle, or the base of this triangular prism, happens to be the same length as this this rectangle on the back wall, or the back side, and that happens to be 8 centimeters in length, or you might think of it as 8 centimeters in height if you're looking at it as the triangular prism. So I'm just going to plug an 8 down below here. In fact, what I'm going to do next is just label each length of each rectangle with an 8, because I can see that this rectangle has a length of 8. I'm going to actually just erase this highlighted portion and just highlight just these lengths so we can see them. Well, this rectangle has a length of 8. This next rectangle has a length of 8. And also, this next one has a length of 8. And these are kind of like the table legs of our prism. So they all have to have the same length, or we can look at this as the height of the prism. So they all happen to be 8 centimeters in length. That's why I labeled 8 below on each rectangle. Let's go ahead and just erase this information. I want to highlight the next rectangle. It's laying on this side. The rectangular or triangular prism's laying on this side that we're going to highlight right now. That does not mean this is the base shape, though. Remember, the base shape are the 2 triangles that we highlighted at the beginning. However, we know the length of this rectangle is 8 centimeters. But the width here, well, it's 4 centimeters. So it looks like I do have 2 rectangles that are not the same size. So this one has a 4 centimeter width. Now I can erase that information. And let's take a look at our last rectangle, which happens to be tilted. It's on our right side, or kind of the front wall here. And we'll highlight that now. So that has the length of 8 centimeters. But where's the height? Well, we don't see it along the front, but we can see it along that back edge again, that back side. So that is 5 centimeters. So the width of this last rectangle has to be 5 centimeters. Let's take a look at something, see if we notice an interesting pattern. Yeah, if we actually look at this triangle, well, it's a 3 by 4 by 5 triangle. So 3 by 4 by 5. And the width of each rectangle, well, it takes up one of those triangle lengths. I have a 3 by 4 by 5 here. That's pretty interesting. Well, let's go ahead and make a note that there I'm not going to write 3 rectangles here. I just want to note that I have 1 rectangle here. In fact, I'm going to change colors again. So I'm just going to call it rec for short. So 1 rectangle here. I have a second rectangle here. In fact, it's not 2 rectangles. There is only 1 rectangle here. So 1 rectangle here and an additional rectangle here. So I have 2 triangles and 1, 2, 3 different rectangles. I have to find the area of all of these shapes, then add them together. Well, how can we do that? I just want to make some dividers here. Let's make a note of what our area formula is for a rectangle. So the area of a rectangle, I'm only going to write it one time, and I'll write it here, is equivalent to the length times the width. Let's make a little bit more space here. Let's actually see if I can just zoom out so that we can still keep the triangular prism in the screen. All right, and I just want to erase that last highlighted portion. Cool. So I'm just going to write the formulas out and substitute values in for all of these formulas. So I'm going to first write out the formula for a triangle. So we have half of the base. Well, the base length is 4, and the height of this triangle is 3. Well, what about that 5? Is that 5 even important for the triangle? Well, it's not necessarily important for the triangle, the formula for the area of a triangle, but don't forget the 5 was included when we looked at the rectangle and we find the area of a rectangle. It is important. It's just not necessarily important for the area of a triangle, that formula there. So we've got this formula written out. I'm going to make one more note here that there are 2 triangles. Now there are a couple of things I can do here. Well, the first thing I can do is take all of this information in this formula, and at the very end I can double it. The reason I can double it is because this information right here gives me the area for 1 triangle, but I'm dealing with 2 triangles above. So at the end, well, I can multiply by 2. I could take 2 and multiply it by this area of 1 triangle and just double all that information. So the formula for the area of a rectangle is length times width. I'm going to take the length 8 and multiply it by 3 in this case. So we have 8 times 3, and then the length here, 8 times 4. So 8, let's put parentheses around that, times 4, and again 8 times 5. Cool. So we're going to take the area of each shape, find out the area of each shape, and then add all of that information together afterwards. So what I'm going to do is put brackets around all of this information. The reason I'm putting brackets around not all of the information at once, but each individual set of information is because I want to find out the area of both triangles before I add it to any other value. I want to find out the area of this rectangle before I add it to any other value, and the same for these last 2 rectangles off to the side. So we want to find all of the areas before we do anything else. Okay, let's see if I can zoom out one more time just so we can keep the triangular prism in that screen or in that shot. Okay, so since our only operation here is multiplication, I could honestly multiply straight through from left to right. However, I've set it up with multiple sets of brackets, so I'm actually going to follow PEMDAS or GEMDAS in this case, and going to take half of 4. That's going to be my first step. So half of 4 will give me 2. So I'm going to rewrite this as 2. That's that first 2 there, times 2. I got this value by taking half of 4, and we're going to multiply it by 3. Okay, all right, so 2 times 2 will give me a value of 4, and let's multiply 4 by 3. and 4 by 3 will give me a value of 12. Okay, so the area of two triangles is 12 centimeters squared, and I'm going to add that information to whatever we get here. Well, 8 times 3 gives us a value of 24. So I'm going to put that information below. So 24 here. I'm going to bring down that addition symbol. So let's go ahead and multiply 8 times 4, which gives us a value of 32. I forgot to put those units, so let's go back here and plug in centimeters squared, again, centimeters squared. And then let's bring down that addition symbol above. So we're going to add here 8 times 5, which gives us a value of 40. So 40, and I want to fix that 0 that I just wrote down. So 40 centimeters squared. So now all I have to do is add straight through from left to right to find the surface area of this entire shape. Okay, I'm going to try zooming out one more time and let's see if it still looks good. All right, I think that we can still work with this problem. So let's go ahead and just change colors real quick. 12 plus 24 gives us a value of 36, so 36 centimeters squared. And 32 plus 40, it will give us a value of 72. So I have 72 centimeters squared here. So how did I get that? I took 12 and I added it to 24. How did I get 72? I took 32 and added it to 40. All right, so we have 36 plus 72. Okay, so 36 plus 72 will give us a value of 108 centimeters squared, but I'm not finished, I'm not complete. I want to make a note that this is the surface area, so I'm going to use a capital S. So surface area is equal to 108 centimeters squared, and then we can box this information up. Cool stuff.